Let us look at the next section now, students. This section contains 10 questions. Each question has 4 options, out of which one or more than one option may be correct. So let us look at question number 29 now, students. Which of the following statements is or are correct regarding the metallurgical processes? So option A, it says cryolite and fluorspar are added to molten alumina during the extraction of aluminium. So this is a correct statement. During the extraction of aluminium, we add cryolite, which is Na3AlF6, and fluorspar, which is CaF2. If you talk about the B option now, native silver forms a water-soluble complex with dilute aqueous solution of NaCN in presence of air. This is also a correct statement. The Ag, when it reacts with cyanide ions in presence of oxygen, the Ag gets oxidized to Ag+, and then it forms the complex with this cyanide ions to form AgCN whole twice negative. So second option is also correct. If we talk about the third option now, calcium can be obtained by electrolysis of an aqueous solution of its salt. This is not correct, students. There is water present in the system. So water has a greater reduction potential as compared to calcium. So it will be water which will get reduced and not calcium. If we talk about the D option now, copper ore contains silica as an impurity and FeO is added as flux to remove FeSiO3 slag. So students, the slag mentioned over here is correct, but the impurity and the flux are exchange. So it contains FeO as an impurity and silica is added as a flux. So this is also not correct, students. So for question number 29, we have to mark the correct answer as option A and option B. Let us look at the next question now. Question 30. Two solutions of Sx and Sy of non-volatile and non-dissociative solutes X and Y are prepared. The molar mass ratio Mx is to My is 1:3. Both the solutions are 5% weight by weight of the solute in water. Now two different solutions S1 and S2 are prepared. S1 contains Sx is to Sy in ratio 2:3 and S2 contains Sx is to Sy in ratio 3:2. Assuming the density of all solutions as 1 gram per ml, the correct relations among the following are. So in this question we have Sx and Sy. So they are both 5% weight by weight of the solute in water. The molar masses are different and the molar mass ratio has been given to us, that Mx is to My is 1:3. So examiner seems to be interested in the delta TF of Sx and Sy and also the delta TF of S1 and S2. So we can first find out the molality of Sx and molality of Sy. So if we talk about molality of Sx, so it contains 5% weight by weight of the solute in water. So if I assume that there is a total of 100 grams of solution, so there will be 5 grams of the solute X divided by its molar mass. So this will give me the number of moles of the solute X. Now this moles have to be divided by the weight of solvent present in kilograms. So we had 100 gram solution. If 5 gram was solute, then 95 gram will be the solvent, and this has to be multiplied by a factor of 1000 to convert this into kgs. So this is the molality of Sx. Similarly, we can find out the molality of Sy. It is also 5% weight by weight. So 5 has to be divided by My now, molar mass of Y, to give us the value of number of moles, and the 95 and the 1000 term are going to be common. So if I talk about the molality ratio of Sx to Sy, so it will be equal to molar mass of Y is to molar mass of X. So this will be equal to 3. So now students, if I talk about the delta TF value, the delta TF of Sx is to delta TF of Sy. So delta TF is given by I into Kf into M. So we have to take the value of I as 1 in this case, and the Kf will be common as it is a property of the solvent only. So we can clearly see that delta TF is directly proportional to the molality. So if I talk about the ratio of the delta TF of Sx and Sy, this will be equal to the ratio of the molalities of Sx and Sy, and delta TF for Sx upon delta TF for Sy will also be equal to 3. So out of option A and option B, we can see that option A is correct, whereas option B is not. Now we have to talk about the delta TF of S1 and S2. So if I talk about S1 and S2, we have an idea that we just have to deal in terms of the molality, as the solutes are non-dissociative, so we need not worry about the I value, and the Kf is going to be the same as the solvent is water in both the cases. So we just have to deal with the molalities of solution S1 and S2. So if I talk about molality of solution S1, so S1, it contains Sx and Sy in the ratio of 2:3. So this can be written as 2/5 into molality of Sx plus 3/5 into molality of Sy. And now if I talk about the molality of S2, students, it will be equal to 3/5 into molality of Sx plus 2/5 into molality of Sy. So we just have to deal with the ratio of these two numbers. So molality of S1 upon molality of S2, it will be equal to 2 times the molality of Sx plus 3 times the molality of Sy divided by 3 times the molality of Sx plus 2 times the molality of Sy. Students, we already have the ratio of the molality of Sx to molality of Sy. It is equal to molar mass of Y by molar mass of X. So we can just divide the numerator and the denominator by this molality of Sy. So this will be equal to 2 times molality of Sx by molality of Sy. So that is equal to 3. So 2 into 3 plus 3 divided by 3 into 3 plus 2. So this shall be equal to 9 upon 11. So students, the molality of S1 is to molality of S2, it comes out to be 9 by 11. And as we had seen before, the ratio of delta TFs for both this solution will also be in this exact ratio. So delta TF for S1 upon delta TF for S2 shall be equal to 9 by 11. So if you talk about option C and option D, we can see that option C is correct, whereas option D is not. So for question number 30, we have to mark the answer as option A and option C. Let us look at the next question now. Question number 31. Among the given pair of complexes, the ones which have a greater value of delta O for the latter complex is or are. So if we talk about option A now, so in option A, we have CONH3 whole 6 3 positive and COCN whole 6 3 negative. So cobalt is in a state of plus 3 in both these complexes, whereas the ligands are different. So if we talk about the cyanide and the ammonia ligands, the cyanide is a stronger ligand as compared to ammonia. So the cyanide ion is going to cause a greater splitting. So the second complex is going to have a greater splitting. If I talk about the B option now, in the B option I have FeCN6 4 negative and FeCN6 3 negative. So iron is in a state of plus 2 in the first complex, whereas it is in a state of plus 3 in the second complex. And students, we know that in the complex having a greater oxidation state of the metal, the splitting is greater. So the second complex is also going to have a greater splitting in this case as well. If I talk about the third option now, I have cobalt 3 plus and rhodium 3 plus with the same set of ligands, which is water. So if I talk about cobalt and rhodium, so this belongs to 3D, whereas this belongs to 4D. And we know that splitting caused in the 4D is greater as compared to 3D. So again, the latter complex, it has a greater splitting or the greater value of delta O as compared to the former complex. If I talk about the last option now, so here again we have cobalt 3 plus in both these complexes. The first ligand is fluoride ion, whereas the second ligand is the oxalate ion. So students, the oxalate ions, they form a chelate. So due to this chelate formation, there is a greater splitting in the second complex. So students, in all of these given complexes, the latter complex has a greater value of delta O. So all of these have to be marked as the correct answer to question number 31. Let us look at the next question now. Question number 32. Which of the given statements is correct regarding the structure of compounds given below? So polymeric BeH2 has 3 center 2 electron bonds with sp3 hybridized Be atoms. So this is a correct statement, students. Polymeric BeH2 exists as a network solid. So it contains sp3 hybridized Be atoms with 3 center 2 electron bonds. So there are 3 center 2 electron bonds present in this case. If I talk about the B option now, polymeric BeCl2 has 3 center 4 electron bonds with sp3 hybridized Be atoms. So this is also a correct statement. If we talk about the polymeric BeCl2, it is going to have this structure. So there will be 3 center 4 electron bonds over here as well. They are indicated. So second option is also correct. If I talk about the C option now, dimeric BH2 has both 3 center 2 electron bond and 2 center 2 electron bonds with sp2 hybridized Be atom. This is also a correct statement. If I talk about the dimeric BH2, so there are 3 center 2 electron bonds and there are normal 2 center 2 electron bonds. So this is 3 center 2 electron bond, whereas this is 2 center 2 electron bond, which is the normal covalent bond. If I talk about the last option now, dimeric BeCl2 has both 3 center 4 electron bonds and 2 center 2 electron bonds with sp2 hybridized beryllium atoms. So we can draw the dimer of BeCl2. So here again we have 3 center 4 electron bonds and we have the normal 2 center 2 electron bonds, and the hybridization of beryllium in this case is sp2. Okay, so all of these given statements are correct, students. For this question we have to mark all of these as the correct answer. Let us look at the next question now. Question 33. In the Wittig reaction, the conversion of a carbonyl compound to give an alkene is done with phosphorus halide. Consider the reaction sequence. So we have been given a reaction and we have to comment on the correct statements out of the one given. So if I try and figure out this reaction sequence, students, so we have PPH3 and we have CH3Cl. So this PPH3 is going to make an SN2 attack over this CH3Cl and leading to the formation of the phosphonium salt as shown. Now students, the BuLi, it contains the Bu minus, which is a very strong base. It is going to extract a proton from this sp3 hybridized carbon atom, and the negative charge generated over here will be stabilized into the vacant d orbital of this phosphorus. So we are going to obtain CH2P PH3. Now it is allowed to react with Y, and reacting it with Y leads to the generation of this compound. Now students, we know that the Wittig reaction is a double bond exchange reaction. So compound Y must be cyclohexanone. So what we do over here is we just exchange the groups present on the double bond. So the CH2, it goes to the cyclic ring. It is doubly bonded with the cyclic ring, and the oxygen, it comes over here to phosphorus. So we have the formation of POPH3. So we can now try and label the unknown compounds in this equation. We have this as the X, we have Y as cyclohexanone, and we have Z, which is containing P as POPH3. Let us now look at the options which are given to us. So option A, it says BuLi extracts a proton from the sp3 hybridized carbon atom. So we can see that during the formation of X, the Bu minus, it extracted a proton from the sp3 hybridized carbon atom. So option A is correct. If I talk about option B now, X is CH2PPH3. So this is also a correct statement. If I talk about option C now, Y is cyclohexanone. This is also a correct statement. And if I talk about the last option, Z is POPH3. So this is also a correct statement. So all of these given statements have to be marked as the correct answer to question number 33. Let us look at the next question now. Question 34. Consider the given statement regarding F block elements and select the correct ones. So option A, it says actinoids are slightly affected by nitric acid. This is a correct statement. Nitric acid leads to the formation of an oxide layer which further prevents its reaction with the nitric acid. If I talk about the B option now, actinides are not affected by hydrochloric acid. This is not correct, students. Actinoids upon reaction with hydrochloric acid liberate hydrogen gas. If I talk about the C option now, actinoids react with boiling water to form oxides and hydrides. This is a correct statement. Actinides react with boiling water to give this reaction, forming oxides and hydrides. If I talk about the last option now, actinoids generally show an oxidation state of +3. This is also a correct statement. So out of these given statements, option A, option C, and option D have to be marked as the correct answer. Let us look at the next question now. Question 35. In the desorption process, assume that the rate constant of desorption follows an Arrhenius type relation. Consider the following statements and select the correct ones. Option A, it says greater the desorption activation energy, greater is the time spent by the adsorbed particle on the surface. So this is a correct statement, students. As the desorption activation energy is greater, it means that desorption is difficult as compared to adsorption. So it means that the time spent by the adsorbed molecule will be greater. If I talk about option B now, greater the temperature, lesser is the time spent by the particle on the surface. This is also a correct statement. As the temperature increases, the desorption process, it also increases. So if the rate of desorption increases, it means that the time spent by the particle on the surface is going to be lesser as the rate has increased. If I talk about the C option now, time spent by any particle on the surface is independent of its nature. This is not correct, students. The interaction between the adsorbate and the adsorbent plays a very significant role in the time spent by the particle on the surface. So option C is not correct. If I talk about option D now, the activation energy required for desorption is generally greater than that required for adsorption. This is also a correct statement, students. If I talk about delta H adsorption, it is generally negative. It means that the EA forward minus EA backward has to be less than 0. So EA forward is the EA for the adsorption process, and EA backward is the activation energy for the desorption process. So from this equation we can directly see that the activation energy for desorption is greater than that required for adsorption. And for question number 35, we have to mark the correct answer as option A, B and D. Let us look at the next question now. Question number 36. Consider the given PV diagram for 1 mole of a gas undergoing a cyclic process. So we've been given a PV diagram and we have to comment on the correct statements out of the following. So option A, it says along C to A, the temperature first increases and then decreases. And option B, it says along C to A, the temperature first decreases and then increases. So if I talk about this point C and point A now, students, so the product of the pressure and the volume at both C as well as A are equal. So they are both equal to 10 atmosphere liters. So it means that the temperature at A and temperature of C shall be equal. The next question that might come to our minds is whether the line C to A is an isotherm. So that is not correct, students. The line C to A is not an isotherm. So PV isotherms come out to be rectangular, hyperbolic and not straight line. So this is not a constant temperature line. So it must mean that the temperature must have changed in between. Now to figure out whether the temperature has increased in the beginning or decreased in the beginning, we have to do some further analysis. So we'll quickly get down to that. We can draw the PV diagram. So I have pressure on the y-axis and I have volume on the x-axis. I have 2 points A and C which are having the same temperature. So if I try and draw an isotherm, students, the isotherm will be drawn in such a fashion. The actual line also we can draw. The line connecting A and C was a straight line. So if I try and draw parallel isotherms over here, so parallel isotherms will be drawn in such a fashion. And now we know that if we compare these 3 isotherms, we can clearly see that the one which lies below has the least temperature. So this temperature, it goes on increasing up to a certain point. So at that point, the line CA will be a tangent to this curve. So there will be only one point of contact. So if we talk about this intermediate point D, let us call it as D. So from C to D, the temperature is going to be increasing as we have seen. And if I talk about moving further from D to A, so if we move from D to A, we can see that we are jumping onto lower isotherms which are having lesser temperature. So we can clearly see that the temperature first increases along C to D and then it decreases from D to A. So the temperature first increases and then decreases. So option A is correct, whereas option B is not. Let's talk about option C now. Along A to B, the entropy of system increases. So if I talk about A to B, so they are isobaric points and the volume has increased. So if the volume has increased, it must mean that the entropy has also increased. If I talk about the D option now, along B to C, heat is lost by the process. So if I talk about B to C, so in moving from B to C, no work is done as the process is isochoric. So in an isochoric process, the pressure, it decreases. It must mean that the temperature has also decreased. It must mean that delta U has decreased. So if delta U has decreased and the work done is equal to 0, it means that heat must have been lost by the system to the surrounding. So option D is correct. So out of these given options, we have to select the correct options as option A, C and D. Let's look at the next question now. Question 37. The following information is given about a reaction which is catalyzed in the acidic medium. At a particular pH, the half-life of the reaction is found to be independent of the concentration of substrate. whereas at a fixed concentration of the substrate, the rate of reaction is decreased 10 times if the pH is increased by 1 unit. We have to select the correct statements. So students, if I talk about the information which is given to us, so it is mentioned that if the pH is fixed, the half-life of the reaction is found to be independent of the concentration of the substrate. So it must mean that the rate is directly proportional to the first power of the concentration of substrate. Since in a first order reaction, the half-life is independent of the concentration of the substrate. So the reaction is of first order with respect to the substrate. So option A is correct, whereas option C is not. Now if you talk about the second condition, it is mentioned to us that at a fixed concentration of the substrate, the rate of reaction is decreased 10 times if the pH is increased by 1 unit. So if the pH is increased by 1 unit, it must mean that the concentration of H plus ions has decreased by 10 times. So on decreasing the concentration of H plus ions by 10 times, the rate also decreases 10 times. So it must mean that the rate is again directly proportional to the concentration of H plus ions present. So rate is proportional to H plus concentration raised to the power 1. So we can see that option B is not correct. If I talk about the D option now, rate is equal to K times the concentration of substrate into concentration of H plus. So this is also correct, students. The given reaction is of first order with respect to both the substrate as well as the H plus ions. So option A and option D are correct, and they have to be marked as the answer to question number 37. Let us look at the next question now. Question number 38. Consider the tripeptide given below. So we've been given a tripeptide, and the examiner seems to be interested in the amino acids that will be obtained on the hydrolysis of the given tripeptide. So students, if we talk about the hydrolysis of this given tripeptide, so the amide linkages will be hydrolyzed. And if I talk about the 3 amino acids that will be generated, so the first acid will be this one, and we know that this is valine. The second amino acid that will be generated is this one. So it contains a CH2OH at the alpha carbon apart from the amino group. So students, this is serine. And if I talk about the last amino acid on the right that will be obtained, so this amino acid, students, is threonine. Okay, so for this question we have to mark the correct answer as option A, option C and option D. Asparagine is not obtained upon hydrolysis of this given tripeptide.